So we have talked about what is close to us in space, and that described the solar system. And then we went on to look at a little bit farther out and looked at stars. And there are a lot of stars out in the night sky, and they represent a lot of different sizes and shapes and a lot of different energies that come off of them. Some are larger than ours, some are smaller than ours, some are brighter than ours, some are cooler than ours. But by looking at the energies that come off a star, we can actually learn a lot about the star, about what it's made of, how hot it is, how big it is, how massive it is, just by looking at the light or the energies. So we know a lot about stars that are out in the universe. Well, if we start looking even further, we start to find really strange things. And so we're going to look at things that are very far away from us, and things become strange on the edges of the universe. When we actually look out at the night sky, what we see are the planets and the stars that are, okay, now I'm going to use relative terms, that are closer to us. Okay, now planets and our solar system is really, really close, but the stars that we see in the night skies are relatively close to us. It is a collection of stars that is grouped together. It is organized in what's called a galaxy, and our galaxy is called the Milky Way. There are lots and lots of stars in our Milky Way, but each pinpoint of light that represents a single star is within this collection. And if you look at the night sky, there in a very dark area, you see a very dense place where there are stars, and then it gets less and less as you go from the edges. And in one of the videos before, you saw that denseness move across the sky, just like all the other stars. Where you can, it can almost be thought of as like a little island of stars that are all together. And our galaxy is called the Milky Way, and we believe it looks like this. Okay, and in terms of the organization, all right, you can see that there's a center, and it looks like we're spinning around the center of our galaxy, very much like the planets going around the sun, or very much like the electrons going around the nucleus. There seems to be an order in the way the universe is organized. Now, is this a picture of our galaxy? No, it is not a picture of our galaxy, because we haven't gone out that far, turned around and taken a selfie, okay? But what we have done is taken pictures of other galaxies we found in the night sky, which we think is similar in shape to what we look like. Our sun is in the plane of the galaxy, but we're like way out to the edge. Not close to the center, which is called the hub, but way out to the edge. If you take a look at the shape of our galaxy, it can be described like a fried egg. You got a very big center with a yolk, and then we spread out to the edges. Okay? The distances from this edge to that edge is 130,000 light years long, and in our thickest place in the middle, it's 10,000 light years thick. Okay, so that's a lot. But when you look at that particular galaxy, it is by itself separated very, very far away from anything else in the known universe. Our galaxy is called a spiral galaxy. It is like what you see are the two arms. Here is one of them, and here is the second one. We are rotating. And what we now understand is there is something massive in the middle of our galaxy, and we believe all galaxies. So right in the middle, we are kind of look like we are, kind of flushing down, and what's, And we are flushing into the center is a black hole. We are circling that black hole. We know this because of the energies that come from the center of the galaxy and the motion of the stars that are very close to it. They're going faster than calculated as possible unless there is a very massive black hole that is powering them. And so from a lot of data sets that we now have, we do believe that in the middle of our galaxy is a very large, massive black hole. What supports this is types of energies, radio waves and gamma waves particularly, that are emitted. And when we start looking at other galaxies, it seems that almost all of them, we've been able to detect the same kind of energies. And so we believe that the formation of a galaxy requires a black hole in its center to give it the gravitational attraction to bring all of those stars together and to hold the galaxy together. Now, within the Milky Way, there are two kinds of stars. One called population 1 stars and population 2 stars. All right. When the universe was created, we believe that there were only two elements made, hydrogen and helium. Hydrogen is the element that powers the stars in fusion. Now, when we looked at the lab yesterday, did stars only have hydrogen in them? No, some stars had other metals in there. Okay? The only time that heavier metals are made past iron is when? At what stage of a star's life? In a supernova, when they explode. So, on the edges of the galaxy, kind of way away from the center, all of the stars that we see have heavy elements. That means that an older star must have lived and died and exploded to create the heavier elements, and then those gases collected back into a star, and now you have a star that has mostly hydrogen and helium, but it also has the heavy elements. That means it's been formed from stars that have already had a full life, and they are younger. Our star is part of that population. There is the population 2 stars that are centered in the center. They're in the globular cluster here, and they only contain hydrogen and helium. That means from the inception or the creation of the entire universe, the stars in the center are really, really old. They are burning their first amounts of hydrogen. They have not gotten to the stage that they've run out. They haven't gotten to the stage where they blow up and create the heavy metals. And so if you only have hydrogen and helium, you've been burning since the beginning of time, and you haven't died yet. Any star that does have heavy metals have been created after other stars have totally lived their life and have died and have produced this material to create new stars. Now, there are a lot of different energies that are floating around in space, and quite often what we do is we look at the energies, and one very interesting way that we do is using radio telescopes. I'll show you two different telescopes. This telescope is built in the valley of or in a valley range in a mountains area, and this is called Arecibo. It is in Puerto Rico. So this is run by NASA. If you go to the southwest, a lot of universities also have radio telescopes, but this is the radio telescope. A little bit different, right? This is one big dish, and I got a bunch of little dishes, okay? Now, what functionally happens for this type is that the dish effectively is the size of the outer ring. And what they do is they take all of those signals and integrate them. Just like we did yesterday to see the black hole, we took radio telescopes all the way around the world. We basically made a dish the size of Earth, took all of those signals and integrated them together. This is just a smaller version of that. This is a little bit cheaper to make, and so that's why we do that. Okay, so we listen into the night sky, especially when you're talking about radio waves, and there's something very special about what we can detect with radio waves. Okay, I have in the room right across this classroom a instrument called an NMR. Okay, what it does is it uses a really big magnet to create radio waves. Okay, and we hit organic molecules with this big energy, and we detect the radio waves that come off of the molecules, and then it puts out a signal pattern, which I teach the chemistry majors how to read, and they can actually, based upon what they see and the signals they see, they can determine what the structure is. Well, in space, we also have these kinds of things that happen, and organic molecules can be hit by energies, and they put off radio waves. We can detect them. There are organic molecules, molecules that have carbon, hydrogen, and oxygen in them that are floating in space. One of the most often seen organic compounds is in the form of a gas, and the largest concentration of organic molecules that we have identified are gases of what's called ethanol. Do you know what ethanol is? Yep, that's drinking alcohol. We have tons and tons of drinking alcohol all throughout space. Okay, and so we find these kinds of molecules just floating in space. We also can find energies from radio waves from stars that have ions in them, and supernovas give off radio waves. So if something is exploded, we can see where it was. Also, lots of times electrons trapped in magnetic fields. So a lot of different entities give off radio waves. One advantage about using a radio telescope, those kind of astronomers can actually do their work in the daytime. Most other astronomers can only do their work at night. And so the radio telescopes work all day and all night, and the time on those scopes is very jealously guarded. And so there's one more thing I'll talk about in just near the end of the chapter. Radio telescopes are the way that we listen also for the possibility of another intelligent race out there. It was actually funded by the government. It was a project called SETI, the Search for Extraterrestrial Intelligence, and they used these types of telescopes. It is not funded by the government anymore, but it is privately funded. There are other things that are in space. Cosmic rays are really bits of material, usually hydrogen, okay, or hydrogen nuclei, that are traveling almost at the speed of light, and they are very bad for us because they carry a lot of energy. We know that primaries exist because the creation of carbon-14 is actually the interaction of primaries that hit our atmosphere to create the carbon-14 from nitrogen. And so we know that there's a lot of cosmic rays out there that are dangerous to us. This makes it actually dangerous for astronauts to actually go out into space. Even in the International Space Station, remember that was kind of partly in our atmosphere, in one of the layers of our atmosphere? The International Space Station lies within our atmosphere and within the magnetic field, so being there is dangerous but not as dangerous. But if we fly past or away from our magnetic field, these are the kinds of things that challenge going out into space, because the exposure to these kinds of energies are damaging to biological systems. There is theories that if we do go to Mars, the length of time, which can be as short as 6 months, depending upon where the two planets are in their orbit, there is ideas that could astronauts actually spend that amount of time and not be exposed to so much radiation that it wouldn't be a one-way trip. Not normally talked about in the news, not in the talk about going to Mars or space exploration, but this is a big problem that NASA has been trying to battle and trying to come up with ways to protect astronauts.